now. I'm gonna do all of them for the second half of the assignment. And I feel like for 542, that should be really helpful for you to see them all together. Now, I'm not gonna do it where I make one, I'm just gonna kind of do them separate. You can arrange them how you like, okay? So the first step is we need to make a segment bisector. So first, let's just make a segment. There's my segment, okay? A segment bisector, so I'm gonna go through them one at a time. This is A. We're just gonna go ahead and do a double fish here. More than halfway, I go more than halfway, and I make my double fish. Okay, make my double fish. Now what that allows you to do is know, and you know what? This is segment bisector. This is also perpendicular bisector. They're the same thing, we just use them for different things, okay? So perpendicular bisector is gonna look at those intersections, and also for a bisector, it's gonna look for those bits. And what we have here is both a perpendicular bisector and a segment bisector. Segment bisector, because both those sides are exactly the same. Perpendicular bisector, because the line is 90 degrees going through the double fish, and that gets rid of A and C. Okay, now we're gonna go to B, and let's do, so this is a segment bisector. This is a perpendicular bisector. This is an angle bisector. Okay, so this is now the angle bisector. And for that, you know, you just have to make an angle and bisect it. Okay, so here's my angle that I'm going to be using. Let's call it angle D. And we will first start by making an arc from D out here. Okay, so the reason I did A and C, segment bisector and perpendicular bisector up here together, is because it's the same process. I'm showing you different processes, okay? So angle bisector, and I can't slow down for this because I don't have much time, so I'm not gonna slow down. You have to watch this video to review these as you need to. If I'm gonna break this angle though, I make my arc from the radius, and I keep an angle, I keep an opening of my compass that goes more than halfway. And, whoops. I make my double fish. All right, so if you know these and you just want to start kind of working on it, that's fine too. If you don't know it, just keep watching. Okay, so look, here's my angle bisector. Remember that double fish always cuts it in half, always cuts everything in half. So look, here is my new angle bisector. Okay. Now, if I wanted to know a fourth of an angle, I would do another double fish right here and make another ray to have a fourth. Okay, so when we do an angle bisector, you can keep cutting it in half, cutting in half, cutting in half, cutting in half. Okay. All right, that's D. Let's do parallel lines. Okay, so I'm going to make a parallel line to this line here. And I'm going to start by making one perpendicular line. This is like making the goalposts. Remember, we make our goalposts, and then it's like soccer. Okay, you make a goalpost, and then you cut off on the top how high you need them to be, and then you know it's going to be parallel to the ground. So I first need to make a perpendicular bisector, or perpendicular line right here. And what I'm going to do is put a point. Here's where my goalpost is going to go. Now watch. I need to start by making an arc around that post. And what this does is it gives me 2 points, right? 2 points on either side that are exactly the same distance. These 2 points are going to help me make my double fish, which gives me a perpendicular bisector between these 2 points. Okay, so watch. I'm going to go ahead and I make my arc around a point that I chose. I make one side of the double fish. I make the other side of the double fish. And what I've just created is a perpendicular line. Okay. Now that's one side of the goalpost. That's one side. We're going to do another side, and then all we have to do is make them the same exact height, and we're good. So let's do the exact same process. I'm going to put my other post there, and first I need to make sure that I have them have this one arc here. And why do we do this again? Whoops. We do this arc here because I want to put a perpendicular line up here. So you need an equal distance away from that point in order to make your double fish in between. Yeah, I'm going to post this right after class. Yeah, this is going to be like the go-to video for reviewing this, right? Because our test that we're going to have is going to be really hard for me to grade because I'm going to have to go in and look at every single construction mark you make to make sure you know how to do it, okay? So here we go. We're going to go through this point now. And there's my other perpendicular line. Let me see. And now it's just like this. It's like we dug a hole for our two goalposts. We know it's wide enough. And then we just have these tall posts here. We got to cut them off at the same height. If you cut them off on the same height, right? If you cut them off here, is that a goal? Would you like to be a goalie defending that goal? No, because they would just kick it right here and you wouldn't even be able to reach it. So this is the last step. And it doesn't matter how high the goal is, right? You get to make that up. But I keep the radius the same, and all I'm going to do is go from this point. And I'm just going to mark where the height is going to be. Go here, mark where the height is going to be. You see? Now I've marked where the height's going to be, and all I need to do now is connect them. Okay? And what we've just done is create parallel lines. So I put these little arrow marks here to show the tick marks here show that they are parallel. But again, it's equal distance. Remember I taught you the equal distance method? As long as I make two perpendicular lines and make an equal distance measurement from the line of reference to the new line, then I know it's going to be like train tracks. It's going to be equal distance and parallel. Boom. All right. Next, equilateral triangle. Equilateral triangle. All right. Equilateral triangle is starting at a point. I'm going to make a circle. All these are inscribed in a circle, and really we use the circle. We use the circle and what we know about the circle. You know, it has the same radius, all that. We use the circle to get an accurate reading here. Okay, so to start, you keep the same. You put a point on the circle, and you keep the same radius. It's going to go through the center, and you're going to make an arc right there. Whoa. This might not be perfect because you see how I missed the circle. I missed it a little bit. That's fine. Look, these 2 points now that we just had the arc circle intersection. Now, all we have to do is make sure we know how far apart those are. Boom. And we just measure that into our third side over here. I just make a little mark. Right? So again, I measure the opening of those intersection points. I go to one of my points and I make the same distance over here so that now this is my third vertice and I can connect the dots. All you've been wanting to do is connect the dots. And how are we going to show that this triangle is equilateral? I'm going to put tick marks. Boom! That's it. So again, I make a circle. I keep the same radius. I make this arc over here to create 2 intersection points. I find how far apart those intersection points are, and then I make a little mark on the opposite side to give my third vertice and connect them. Boom, 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 boom. All right, almost done. Number F. Oh, F. All right, let's go ahead and make a hexagon. It's a regular hexagon. All right, let's make it around this point. Come on now. Let's make it around this point. And I go and I first make my circle. Circles. There's a circle. All right. And then what I'm doing is I'm taking the same radius. Boom. And all I do is I'm going to start at one point and I'm going to go all the way around the circle. And it works out. It works out. It's beautiful. It's beautiful. Here we go. One mark. Go to that mark. You see I just made that mark? Go to that intersection point. Make another mark. Keep going. Keep going. Don't stop. Make another mark. Keep going. Don't give up. Make another mark. I know you're tired, but do it again. Boom. And then look, if you did it well, the last mark goes back to the same starting point. And this is where these points can be connected for a regular hexagon. What? It's true. Watch. Boom. Boom. Point to dot. Straight edge to point. Pencil. Sorry. Pencil to dot. Point. Straight edge to pencil. Aim. Make your line. Fastest way to do it. There might be a faster way. I don't know. All right. And then we could show that these are all the same. Regular hexagon. Boom. All right. Now I'm going to do square and regular octagon together just because I have done them. And they are, so this is F and H. Okay. So last one here is going to be square and regular octagon. Okay. So let's make that around this point here. Okay, some of you are working on them. That's great. If you still don't have these materials, then this video is going to be perfect. You'll have to get all of them down through your practice on your own, but this video probably will help you a lot. So there you go. Okay, there's a circle. Now a square, remember, we start off by just throwing down a diameter. And as long as it goes to the center, there's no wrong way to make a diameter. If it goes to the center, it cuts it in half. What? It's true. Now we're making a double fish to have a perpendicular bisector, which gives me my other diagonal, and it will be 90 degrees to this line. So I make my quick double fish, getting better at it every day, and I'm going to go through these intersection points right through the center. Boom, 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 boom. Perfect. There's my new points. All right. So this is en route to have a square because we made two diameters that are perpendicular to each other, and essentially everything. If you're like, what do I do first? I'm not sure. Try making a double fish. The double fish is involved in everything. Okay, so I dropped a diameter. I used the two intersection points to find a perpendicular bisector between it, which is going to be in the center and perpendicular to the first diameter. The intersections along the circle are connected to make your square. And the square is... This is the first time we've used different tick marks, but I'm showing that these are the same. If they're all on the same page, you got to use different tick marks for your different shapes, but that's not a huge change to what I'm doing here. Okay, now let's go ahead and make two more double fish, and we are done with the assignment and the class. What? That quick? Yep. Double fish, double fish. I'll do one at a time. Okay, there's the points on the double fish. I'm going to line that through the center and make my other diameter. All the ones we're making here are all diameters. They all go through the center. Okay, and more than halfway, let's make a double fish. This one has a long tail. Weird. It's the weird one. It's good to be weird. All right, here we go. Boom, boom. Here's my other points. Okay. So essentially what we did was we made a square, and then we broke the angles in half. And now we have, coming up, what's it going to be? What's twice a square? Twice a square? That's not the proper way to say it. But what is, there's a correct way to say that. I don't remember. What is the topological transformation between square and octagon? 2. All right, there we go. There's the octagon. An octagon is just 2 times a square. Okay. So we had segment, bisector, and perpendicular bisector, same process. Angle bisector. Parallel lines, we made the 2 goalposts and cut them off so that they are the same height. Equal distance shows that those lines are parallel. Then we had equilateral triangle, right? Regular hexagon, making your way around from point to point, all the way around. Square, double diameter, and then connect those points, break the angles in half, then you have 8 vertices, and that concludes all the construction shapes. Wow, amazing. All right, so that is the 542 breakdown, and I'm going to stop the video, but what do you guys think as far as, as far as being able to do these constructions on your own? What do you think? Give me a scale from 1 to 5. Nice. Boom. All right, thanks.